Right now, humanity is quietly building the largest technological structure ever placed in orbit. Thousands of satellites are circling the planet in a vast network of moving lights. Most people see Starlink as a clever solution to slow internet, and that is exactly what it does. It beams high-speed internet from low Earth orbit to places where fiber cables and cell towers simply cannot reach, including remote villages, ships in the middle of the ocean, and aircraft flying across entire continents. But thinking Starlink is just an internet service is like thinking the Transcontinental Railroad was only about laying tracks. The real significance is much bigger. Today, Starlink already operates more satellites than the rest of the world combined, and SpaceX plans to launch thousands more. To understand why, we need to talk about the economics of becoming a multi-planet species. Building a permanent human presence on Mars would require an extraordinary amount of money.
We are not talking about billions. We are likely talking about trillions. Traditional space companies rely heavily on government contracts and slow development cycles. So SpaceX needed something different, a global business capable of generating enormous continuous revenue. Starlink could become that business. If it captures even a fraction of the global telecommunications market, analysts estimate the system could eventually generate tens of billions of dollars every year. That revenue could help fund the development of the massive Starship rockets designed to carry cargo and eventually humans to Mars. In other words, the satellites above your head may be helping to finance humanity's next planetary frontier. But hidden inside this vision is a serious challenge. Low Earth orbit is becoming crowded. Thousands of satellites, old spacecraft, and fragments of debris are already circling the planet at incredible speeds, and even a tiny fragment can destroy a spacecraft if it collides at orbital velocity. This leads to a frightening scenario known as the Kessler Syndrome. In theory, one collision could create a cloud of debris. That debris could trigger more collisions, and those collisions would create even more debris. In the worst case, low Earth orbit could become extremely hazardous for satellites and future missions. It is a cascading chain reaction scientists have worried about for decades. Ironically, the same orbital infrastructure helping fund humanity's expansion into space could also increase the risks in Earth's immediate neighborhood. However, modern satellite systems are designed with these dangers in mind. Starlink satellites actively maneuver using onboard thrusters to avoid potential collisions. They are constantly tracked from the ground, and when their mission ends, they are designed to burn up in the atmosphere rather than remain as long-term debris. It is a delicate balancing act between massive opportunity and real risk. On one hand, we are building an unprecedented global communications network. On the other hand, we are learning how to responsibly manage an increasingly busy orbital environment. So, what exactly is Starlink? A revolutionary internet system, a powerful commercial engine, and possibly one of the financial foundations for humanity's expansion beyond Earth. The satellites above us may not just be connecting the world, they might be helping to build the first bridge to another planet. Thank you for watching. Please like this video and subscribe to the channel for more explorations into science, technology, and the future of humanity. And let me know in the comments, do you think mega-constellations like Starlink are worth the risks if they help humanity reach Mars?